Hello students, so let's try to solve one more problem from TIFR 2024 and it's a question number 22 and this is from the special theory of relativity. So what is this particular question? So there is a consider a spaceship, so this is a spaceship whose length is L, so that is proper length and moving relativistically into x direction with a speed Vx with respect to some inertial frame, so you can have some inertial frame F. And in as a light bulb is placed from the left and it will travel up to point A to B and there B is a detector. So what is the time taken for light to travel from A to B in a reference frame F? So what should be the time such that light pulse will travel from A to B from F reference frame? So it's a very simple question, straightforward question, and you will see that it was the first question we have solved in our special theory of relativity with the help of Lorentz transformation. So you can use Lorentz transformation, you can use all other concept also, but we will just go for the basic, and that is nothing but what? Lorentz transformation. So what is this particular question? So what we will do, first we will try to figure it out, everything from S dash frame and what is S frame. So I will keep this spaceship as S dash frame and F is my S frame. So this is my spaceship and this spaceship I can assume this is my S dash frame and this is my S frame and which is your F frame in the problem. So this is given. So this is your particular, so what will be, so suppose light pulse will emerge at time t1 dash with respect to S dash and reach here at t2 dash. So what will be t2 dash minus t1 dash, that value is nothing but L upon C. So this is information, and from the S frame we can write this time is what? T2 minus T1. And what will be your T2 minus T1 once we will go for this particular Lorentz transformation? Then this value we can write T2 dash minus V x2 dash upon C square root under 1 minus V square C square minus, we can just go for here, that value is T1 dash minus V x1 dash root under 1 minus V square upon C square. And also we have x2 dash minus x1 dash is equal to L. So what we will do? We will just go for this particular, we will take the time part separately and the space part separately, and V will be nothing but the speed of S dash, that value is Vx. So how we can go for that? So T2 minus T1 is equal to T2 dash minus T1 dash root under 1 minus V square C square plus here we have x2 dash minus x1 dash upon and V upon C square is also there. So V upon C square root under 1 minus V square upon C square. And what is your T2 dash minus T1 dash? That value is equal to L upon C plus x2 dash minus x1 dash is equal to L, and here we have V upon C square, and here we will go for 1 minus V square upon C square. So we can take L by C common. So I am just using this space. So we will take L by C common, and what we have? We have 1 plus V upon C and root under 1 minus V square upon C square. And we can easily write this whole thing as, so this will be your delta T, that value is L upon C root under 1 plus V upon C upon 1 minus V upon C, and here we will put V is equal to Vx. So delta T is equal to L upon C root under 1 plus Vx upon C upon 1 minus Vx upon C. So this is a quite simple problem. Only what you have to do, you have to understand what is your S frame, what is your S dash frame, and accordingly you can write the complete information of the system. Once you will write the story in a mathematical form, that is more than enough to solve any question. So just try to think how you will write each and every concept in a way it is given. So obviously I am again revising. So this thing is given, And what you have to do? You have to calculate this thing. Now you can also calculate what will be the effective distance that light is going to travel. So that means you have to calculate x2 minus x1. So just do it with yourself. So students, in a TIFR question, every question is very, very conceptual. And you have to hit the question from the very basic of that concept. Thank you.